Hello, and welcome to Limits for Finite C. Let us first begin with the definition of a limit. A limit allows us to describe how the outputs of a function behave as the inputs approach a particular value, in our case c. For example, limit of f of x as x goes to c is equal to L. This means that the limit of f of x as x approaches c goes to the point L. Now, c, provided earlier, is the x point at which you want to find the y point, in cases where you can't find it algebraically or graphically for most times. Now, if you thought this was going to be simple, it's not. There are properties of limits. There are 6 different properties given the two equations: limit of f of x as x goes to c is equal to a, and limit of u of x as x goes to c is equal to b. The first rule for limits is the sum rule. This is the limit of f of x plus u of x as x goes to c is equal to their products, a plus b. The second rule is called the difference rule. This states that the limit of f of x minus u of x as x goes to c is equal to a minus b, their products. The third rule for limits is called the product rule. This states as the limit of f of x times u of x as x goes to c is equal to the products a times b. The fourth rule, called the constant multiple rule, states as the limit of f of x times k as x goes to c is equal to k times a. In this case, k stands in for a constant. It could be any value. The fifth rule is called the quotient rule. This states as the limit of f of x over u of x as x goes to c is equal to a over b. And this is only true if b doesn't equal 0, because if b is equal to 0, it will be undefined. And the sixth and final rule of limits is called the power rule. This states as the limit of f of x as x goes to c to the r over s is equal to a to the r over s. And this is only true if s doesn't equal 0, because like the previous rule, it would be undefined. Now, sometimes limits approach different values from opposite sides, and this seems like a huge problem, but it can be solved. It is solved by using right and left-hand limits. An example of a left-hand limit is the limit of f of x as x goes to c from the negative side, denoted by the negative symbol above the c. But the right-hand limit is very similar, as stated by the example, the limit of f of x as x goes to c from the positive side, denoted by the positive value symbol on the top of the c. Now, there are a few known ways to find limits. The first is called the known limit. For example, the limit as x goes to 0 of sine x over x is equal to 1. The second way is by substitution. For example, multiplying by a constant to allow for simpler application of the limit. The third way is by graphing. This is not always applicable to certain equations, so you have to be careful with it. And the fourth is called as Bapper. The fourth way, as Bapper, is called algebraically simplifying before applying previous rules. An example of as Bapper is the limit as x goes to 2 of x squared minus 4 over x minus 2. Now, using as Bapper, you can make this to the limit of x goes to 2 of x minus 2 times x plus 2 over x minus 2. Again, using as Bapper, you can cross out the two x minus 2's and just make it the limit as x goes to 2 of x plus 2, which is equal to 4. Continuing with this problem, the limit of x squared minus 4 over x minus 2 as x goes to 2 is graphed by the graph right here. As you can see, there is a hole or discontinuity at x equals 2 or y is equal to 4. And this is because if you put in x is equal to 2 for this equation, you will get an undefined answer. Thank you for watching today, and remember, always use the rules and as BAPR. As BAPR is truly one of the most important things to limits for calculus, and I hope you continue your calculus learning. I hope this helps your knowledge, and thanks for watching.